Hello everybody. Now for this project I've been tasked with creating a local AI assistant on a Raspberry Pi 5 board. So in the past I've done a lot of projects on the Arduino Uno board, which is this one. So this one's a little microcontroller. It's a little bit smaller than a credit card in size, so it's quite small and compact. With this one, they're very, very cheap. I can pick this up for about $40 Australian. So very cheap and easy to purchase and use. So with this one, it's used in electronics and programming projects. So with the Arduino, it's a microcontroller based platform designed for simple single operations. It's ideal for controlling hardware components such as sensors, motors, LED lights. The Arduino boards are based on the 18 Mega family of microcontrollers, so they offer 8-bit architecture, limited RAM, so down to about, up to about 2 kilobytes. Also a clock speed of 16 megahertz. They're highly power efficient though, so they consume only around about 200 microwatts of power and are very cost effective. The only thing though, they lack multitasking capabilities. This board doesn't have internet connectivity. Some of the large boards do have Wi-Fi, but this one doesn't, and not really suitable for computational intensive tasks. Whereas with the Arduino Raspberry Pi 5, I should say, board, this one again is also small and compact in size. So this one's pretty much credit card size, quite small. They're relatively cheap as well. This one I can pick up for around about 150 Australian dollars. This one's actually every bit as powerful pretty much as my laptop. In a small size, so they're way smaller than a laptop. So with this one, it's actually a single board computer, so it's capable of running fully fledged operating systems like Linux. It's equipped with a 64-bit ARM processor, can handle significantly more RAM. So they come in 2 gigabyte, 4 gigabyte, 8 gigabyte and 16 gigabyte RAM models. This one is an 8 gigabyte model, which is suitable for what I want to use it for. Also, it has a clock speed of 1.4 gigahertz, so it's a lot quicker than the Arduino Uno. It supports multitasking. It's got internet connectivity via Ethernet or Wi-Fi. Can also handle complex applications such as AI, machine learning, and multimedia processing as well. I can set it up as a web server as well to run web pages locally, so it's really powerful. It does consume a lot more power though, up to 700 megawatts for this one, microwatts I should say, and it's relatively more expensive, so about $150 compared to $40. So with the Arduino, they're better suited for real-time hardware focused tasks. You can use them for controlling traffic lights, for example. You'll also find them in a lot of home appliances such as toasters, kettles, microwaves, washing machine, for example. Probably the best example is a light that turns on automatically when the light level gets low, when it gets dark. Also for sensing lights, so when they detect a person walking by, they might turn on. So just applications like that. So single-use applications. They are really efficient though. They do it really well. They just do the same application time and time again. So it might be used to receive a input from a button clicking to turn on a light, for example. So the software that's embedded on the code pretty much just continuously listens for the button to be clicked and then turns on the light, for example. So yeah, it's ideal for beginners and simple electronic projects, whereas the Raspberry Pi 5 is better for more advanced multifunctional applications that require significant computation power. So with this one, I've got the there's the Raspberry Pi board. Also on top of that, I've installed a AI hat. So with this one, it's a Halo AI hat. I've installed already on the top of the Arduino board down, the Raspberry Pi board down the bottom. With this one, it's really powerful for AI applications. So it can handle 13 trillion operations per second, this one. You can also get it up to 26 trillion operations per second, but 13 trillion is operations per second is perfect for what I want to use it for. So with this one, it can handle high process object detection, for instance. It can handle hosting a local large language model on it. So similar to ChatGPT, except nowhere near as powerful as ChatGPT, as you can imagine there. That's hosted on multi-million-dollar server farms, whereas this one's hosted locally on a local Pi. But the benefit of this one is it's completely private, so your prompts and things aren't getting saved in the cloud and being available to the people at ChatGPT. This one's hosted entirely locally, so it's entirely private. Also, there's no restrictions or constraints on the large language model locally as well, and it actually operates really quickly too, so it's really good for that purpose. So with this task, for this project, I've been tasked with hosting the local large language model on the Raspberry Pi 5 board. So for this, I'll be using the Tiny Llama large language model, quantized down to 4 bits, so it can be hosted on the Raspberry Pi 5 board and only uses up about 4 gigabytes of RAM. It's half the RAM I've got, as used by the large language model. Also with the camera, this one can fit up to 2 cameras, so I've got the camera board already attached via its cable. So we're tasked with also using the camera to detect when a person's in field of view of the camera and then greeting them with speech, and also to include wake word detection. So if someone says the wake word, the camera Raspberry Pi 5 AI assistant records it. Once it detects the wake word, it then asks, "How can I help you?" for instance. So you can think of it such as "Hi Jarvis" or "Hello Siri," things like that, to wake up the agent and get it to talk to you. So I won't go into that for now. I'll leave that for my demonstration of the AI assistant. So with the Raspberry Pi, again, I can attach up to 2 different camera modules to it for object detection, AI surveillance camera purposes, things like that. We also have here an Ethernet port, so I can connect to the internet and the home office network. There's also Wi-Fi available and Bluetooth. We also have 2 USB 3 ports, 2 USB 2 ports. There's 2 micro HDMI plugs as well. There's a USB-C power plug as well, and also there is a slot underneath to store a micro SD card that holds the operating system, the Raspbian operating system for the Raspberry Pi 5 board. So with this one, it's 256 gigabytes. So it can easily store the operating system and also all the Python scripts I'll be using to run the AI assistant on top of that. And so also I have a 7-inch HDMI LCD touchscreen display monitor that plugs in via its cable to the Raspberry Pi 5 board. I have a Bluetooth speaker as well, which will be used by the AI assistant to speak to me. I have a USB dongle for wireless dongle for the keyboard, also a mouse. So I need these to be able to type in and control the display on the HDMI 7-inch display as well. On top of that, I have a USB microphone as well. So this one records what I'm speaking to the AI assistant as well. And then we have the power cable that plugs into it to give it the power it needs. Furthermore, I've also already printed out a couple of parts I'll be using as well. 3D printer. So this one's the back case and front cover for the LCD screen, as well as a bracket to hold it up. And then I've printed out a back cover and front cover for the Raspberry Pi, and also a couple of brackets for the to mount the camera in place. So I'll put them all together now. I won't show myself doing that on the video here, just to save time. Then I'll come back with them. It's all assembled and ready to go. Now I've finished assembling all the components together for my Raspberry Pi and display. So I've assembled the display screen now, the 7-inch HDMI LCD display with its cover to support it. On the side we have the HDMI cable going to the mini HDMI connector on the Raspberry Pi. I also have the USB power connector to the Raspberry Pi at the front, the USB connection point for the power cable. Below that, it's a little bit hard to see, so below that we have the USB dongle, the wireless dongle for the keyboard, the mouse, the orange one, then the black USB microphone, and down the bottom in there is the micro SD card now, which contains the Raspberry operating system for the Raspberry Pi, all loaded up. And we have the camera mount on top now with the bracket holding the camera in place. So that's all good to go. All I need to do now is just to plug the power cable into the USB-C power, the USB-C power connector, and we're all good to go. So in the next video I'll be demonstrating the AI assistant and how it works.